Okay, now we are doing 16 through 20. And problem number 16, you're asked to find the product of 5 cosine 30 plus I sine 30. And you're multiplying that by 2 cosine 90 plus I sine 90. Okay, and the formula for this is to multiply the two R values, which are the 5 and the 2. So 5 times 2 is 10. And then what you do with the items in the parentheses is you just add the angles. Okay, so it's going to be cosine of 30 plus 90 on the cosine, 120. And whatever angle you get here, of course, you're going to get the same thing on the sine term, on the imaginary term. 30 plus 90, sine of 120. Now they've asked you to get this answer, this product, in rectangular form. That means you have to get rid of all thetas and R values. So you do that by spinning to 120. Which would be in quadrant 2. Okay, so you've spun to 120. That's where this terminal side or hypotenuse is. That would give you a 60-degree reference angle, and it would make the opposite side square root of 3. 30 would be up here. Therefore, the short leg being across from it would be 1, and because of the quadrant you're in, that would be -1. And then the hypotenuse is 2. Now you continue the problem using these rectangular values, and you're going to replace the cosine of 120 and the sine of 120 with the values off the triangle. So continuing with this expression, cosine of 120 is x over r. That's how cosine's always defined. Sine's defined as y over r. So you know what values to grab off the triangle. Okay, so cosine of 120, x over r would be -1/2. And then on your imaginary term, after the plus sign, it's I. And then sine of 120 is y over r, which is square root of 3 over 2. And then all you need to do at that point is distribute the 10. So you're going to go 10 times 1/2, -1/2. And then you're going to go I times 10 times square root of 3 over 2. Okay, so 10 times 1/2 is -5. And then same thing here, 10 divided by 2 is 5. So on your I term, you would have 5 square roots of 3, and then just hang that I right off the back. And that's your final product. Okay, number 17, you're asked to do a quotient, and you're asked to do 8 times cosine of pi over 2 plus I sine of pi over 2. Divided by 3 cosine pi over 6 plus I sine of pi over 6. Okay, so the quotient formula, only difference between quotients and products is that you subtract the angles. and then with the R values you divide. Now we can't divide 3 into 8 without getting a run-on decimal, so we'll just leave it like that for right now so that we can keep it as an exact value, and then we'll do what we need to do with the cosine and sine terms. So it's always cosine of the angle on the top minus the angle on the bottom. And you'll have that same value for your sine. Okay, so if you want to talk about sixes, 1/2 is the same thing as 3 sixes. And then you're going to subtract 1/6. Okay, so that leaves you with cosine of 2 sixes, which is the same thing as 1/3. And you know that whatever you get here, you're going to be getting the same thing here. Okay, and then pi over 3, because now you need to give this answer in rectangular form, which means you need to spin to pi over 3. If you want to think of that in degrees, it's 180 divided by 3, which is 60 degrees. Okay, so 60 degrees, you're in quadrant 1. So that would make this square root of 3, it would make this a 1, and it would make this a 2. So now you continue the problem using these rectangular values to replace cosine and sine. So it's 8/3 in the front. Cosine, as I stated in the last problem, is x over r. So for cosine at 60 degrees, you're going to get x over r, which is 1/2. And for your imaginary term, you're going to use y over r to replace sine. So y over r would be square root of 3 over 2. Very similar to the values we just used in the last problem, only the signs are different because we're in quadrant 1. Okay, now take this value and distribute it to both terms. Okay, that'll give you, you can reduce this here right now if you want to, which would go, or you can reduce it after you do the product. So 2 goes into 2 once, 2 goes in here 4 times. So it's 4 times 1 is 4 over 3 for your front term. Likewise over here, you're multiplying 8/3. You can put it right here if you can't concentrate on what reduces. But you know, you're going to get the same thing over here. 2 goes into 2 once. 2 goes in here 4 times. And then it's 4 times square root of 3 over 3. Okay, top times top is 4 square roots of 3. And then 1 times 3 is 3 on the bottom, and this back term is your imaginary term. So that's your final quotient. Okay, moving on to number 19. Okay, at number 19, they give you the rectangular coordinates 2, -2, and you're asked to find the magnitude and the direction angle. Okay, the magnitude has this formula. Oops, I think I did these out of order. Well, I'll do number 19 and then I'll go back to 18. Okay, so the magnitude is this squared, the front component squared plus the back component squared. Same thing as the length of the vector. equal to 4 plus 4, which is 8. You can break this down into 4 times 2. Take the square root of this, which is 2. So this comes out from underneath the radical after you've taken the square root. There is no square root of 2, so that's going to remain inside. So that's your magnitude. Next thing you've been asked to find is the direction angle. So you're going to go use the tangent. We're going to find the reference angle first. And this would normally be the definition for tangent. But in this chapter, B is synonymous to the y value and A is synonymous to the x value. So that would give you -2 over 2. You get a value of -1. Now the only kind of triangle that you can get a tangent value of 1 is in the 45-degree triangle. So your reference angle is 45 degrees to give you the right kind of triangle that will produce a tangent value of 1. But in order for it to comply with the signs that you're given here, you have to be in quadrant 4. Positive x, negative y has to be quadrant 4. Okay, positive x, negative y, you're down here with your reference angle of 45. But the true theta is what you're looking to get at this point, which would be where this terminal side is that created this triangle, or the hypotenuse you could call it. So we spun to 360, but just almost 360, but we were short 45 degrees. That puts you at 315 degrees for your true theta. And that is the direction angle, the magnitude, 2 square roots of 2, and the direction angle, 315. And those are your final answers for that problem. Okay, going on to number 18. Skipped that one, so I'll have to go back to that. So in problem number 18, you're asked whether these 2 points represent the same point. You're given 2 polar points, this one and this one. Okay, so all you're going to do is draw them. And if the points both land right on top of each other, then they represent the same point. So if you were going to 273, you would go to 270, and then you would go an extra 3 degrees. Okay, so let's say that's right there. Now let's say that this represents the extra 3 degrees right in here. Now if you trace in the opposite direction the sides that make up this angle right here, you get the vertical angle, which is also 3 degrees. And so what you want to think of is where this side is right here. So if you were to plot, so if I was to plot 273, right here is 273, because I've gone to 270 and then an extra 3 degrees, and you would come out 4 notches. 1, 2, 3, 4. So right there would be that point. Then if you were to plot negative 493, you would go to the angle first, like we always do. So it would be going to 90. This would be the 90 mark. And then you would be going an extra 3 degrees, which would put you right here. So that would be 93. And then instead of going out 4 notches on the 93-degree arm, you would trace back in the opposite direction, putting you right on top of the point that you had just plotted. So both of them land right here. So that point in quadrant 3 represents 4,273, and it also represents negative 493. Okay, and that's the final answer for that. Okay, so we just have number 20 left to do. Okay, in problem number 20, you're given a rectangular equation. X squared minus y squared is equal to 4. And you're asked to put that in polar form, to give the polar version of that equation. So we have two definitions that we learned in this chapter, that x can be represented as r cosine theta. Y can be represented as r sine theta. And those are the two substitutions you're going to use to get rid of x and y. You're trying to go all polar, all r and theta. So x would be r cosine theta, square it, so it says the equation. Y would be r sine theta. Equation says square that also, and then you have a 4 on the right hand side. Okay, if you bring the square in, you're squaring the r as well as the trig function, so it's r squared cosine squared. The square goes on the trig function, not the theta. Likewise here, apply that square to both r and sine. Okay, then when you're given a polar equation, you try to isolate the r. So, oops, that gets a square right there. So if you take out the r squared by factoring it out, you would have r squared times cosine squared theta minus sine squared theta. Because r squared is the common term, greatest common factor, pulled it out. That's how you end up with this. Now from chapter 7, I believe it was, on identities, this is one of the double angle formulas. Cosine squared minus sine squared is cosine of a double angle. So replace that. You want to give the simplest form of the equation that you possibly can. Okay, then isolate the r term by dividing cosine of 2 theta right off of the r squared. Likewise on the other side. And then you're left with r squared is equal to 4 cosine 2 theta. And you could get rid of the square, that would be an equivalent, but then you're going to have to give the positive and the negative version of this side, so you can just leave it at this level. Okay, and that completes 16 through 20.